In the relentless contest of survival, nature perpetually evolves ways to ensure the continuity of life. Two striking specimens in this dynamic tableau are the electric eel and the alligator, each representing a unique aspect of evolutionary genius. When the electrifying defense mechanism of the eel collides with the predatory prowess of the alligator, the ensuing interaction is as fascinating as it is formidable. This video explores these riveting instances of survival strategies, their underpinning mechanisms, and their ecological implications. Nature's food chain and survival strategies. In the intricate web of life, every species forms a crucial link that contributes to the balance of the ecosystem. Each organism, from the smallest microbe to the most gigantic mammal, plays a role in the food chain, with predator-prey relationships being central to these dynamics. The predator-prey interaction is not merely a contest of brute strength, it is, more importantly, a game of survival where adaptability, cleverness, and survival instincts are the determining factors. Survival strategies in the animal kingdom are diverse and multifaceted. They range from camouflage and mimicry to using sheer speed or brute force, from venomous bites to employing intricate social structures. Some animals, like the chameleon, change their colors to blend in with their environment, thus evading their predators. Others, like the gazelle, rely on their speed and agility to escape the clutches of their hunters. Predators, on the other hand, have their ways of ensuring they stay at the top of the food chain. Some use their raw power and strength, like lions, while others, like sharks, employ their superior speed and razor-sharp teeth. Yet even the most successful predator needs to adapt and overcome challenges, as nature continually evolves mechanisms to level the playing field. One exceptional example of a survival strategy is the electric eel's ability to generate high-voltage electrical discharges for hunting and self-defense. It is a testament to nature's resourcefulness and innovation, as it uses a physical phenomenon like electricity to deter potential threats. This electrogenic fish, while not an apex predator, has a formidable defense mechanism that even the fiercest predators respect. On the other side of this interaction is the alligator, an apex predator equipped with brute strength, a robust body, and lethal jaws. Yet, the Amazonian alligator's interaction with the electric eel is a vivid example of how even the mightiest can succumb to the cunning and survival instincts of supposedly weaker creatures. The alligator, like other predators, relies heavily on its physical strength and hunting skills. However, the electric eel presents a unique challenge that the alligator cannot overcome using its traditional arsenal. Electric eels, an overview. Often mistaken for an eel due to its elongated body, the electric eel, or Electrophorus electricus, is in fact a type of knife fish and is more closely related to catfish and carp. The electric eel inhabits the murky, slow-moving rivers and swamps of the Amazon and Orinoco basins of South America. Despite its somewhat ordinary appearance, this creature's singular adaptation sets it apart. Its ability to generate and control electrical currents, an evolutionarily marvel that has spurred endless fascination and investigation. An electric eel's anatomy is a testament to its evolution for survival. It is not a large creature by predator standards. Typical adults measure around 2 meters and weigh up to 20 kilograms. Its elongated, cylindrical body lacks scales, an attribute common among its closest relatives. Instead, a thick, slimy skin coats the creature, which acts as a protective barrier from the electric shocks it produces and the harsh conditions of its environment. However, the electric eel's most distinctive trait is hidden within its unique physiology. Approximately 4/5 of its body is dedicated to its 3 electric organs: the main organ, the hunter's organ, and the sacs organ, comprising specialized cells called electrocytes. These organs are responsible for the eel's famous electrical abilities. The main and hunter's organs produce the high-voltage shocks used for hunting and self-defense, while the sacs organ produces lower-voltage pulses for navigation and communication. These specialized organs arose through millions of years of evolution. The ability to generate electricity is not exclusive to electric eels. Several species of fish can produce low-voltage electricity for navigation and communication. However, electric eels have taken this trait to an extreme, turning a sensory tool into a potent weapon. The generation of such high voltage is an exceptional adaptation in the animal kingdom, born out of the need to navigate, hunt, and defend in the dark, murky waters of their environment. An electric eel's environment plays a critical role in shaping its evolution. The waters it inhabits are often poor in oxygen, so electric eels have evolved an unusual way of breathing, relying on air instead of water. They rise to the water's surface every few minutes to gulp air before diving again, with their highly vascularized mouths facilitating oxygen exchange. This behavior is another fascinating adaptation, allowing the eel to survive in conditions that other fish cannot. The electric eel's diet mainly consists of invertebrates, small fish, and occasionally small mammals and birds that happen to be close to the water's surface. Its dual-mode electric organs allow it to locate prey in its murky surroundings and deliver powerful shocks to incapacitate it. When hunting, an electric eel emits 2 or 3 electric pulses per second. As the eel gets closer to its prey, the electric pulse rate dramatically increases, known as the electric attack, resulting in a volley of high-frequency discharges that stun the prey. The electricity generation mechanism of electric eels. The electric eel's unique ability to generate and manipulate electrical discharges has puzzled and fascinated scientists for centuries. This unusual adaptation is a consequence of a suite of specialized physiological structures, processes, and behaviors that the eel employs for hunting, defense, and communication. The electric eel's 3 pairs of abdominal organs, the main organ, the hunter's organ, and the sacs organ, are responsible for producing electricity. These organs are composed of electrocytes, flattened disc-like cells that function similarly to batteries. Each electrocyte can generate a small electrical potential, and when all these cells discharge simultaneously, they can produce a shock of up to 860 volts, about 7 times the voltage of a standard wall socket. In an electric eel, thousands of electrocytes are stacked, and each one works like a battery cell, with the front and back acting as positive and negative terminals. When the eel locates its prey, its brain sends a signal through the nervous system to the electrocytes, causing ions to flow across their membranes and create a sudden voltage leap. When this happens across thousands of cells at once, a substantial electric shock is generated. Interestingly, the eel has refined control over the discharge process. It can regulate the intensity, frequency, and duration of its electric pulses, tailoring the discharge to the situation. When navigating or communicating, the eel produces low-voltage pulses from the sacs organ, emitting a steady stream of electric pings and interpreting the echoes to understand its surroundings. In this way, the eel effectively sees in the dark, murky waters it inhabits through what is essentially active electrolocation. When hunting or defending itself, the eel uses its mane and hunter's organs to deliver high-voltage shocks. The eel's brain sends a command to the electric organs, resulting in a rapid succession of high-voltage discharges. The high frequency and intensity of these shocks disrupt the nervous systems of the eel's prey or attacker, effectively stunning or deterring them. This dual-mode system provides the eel with a versatile tool that it can adapt to a wide range of situations. Even more fascinating is the electric eel's ability to manipulate its electric field to induce involuntary movement in its prey. By altering the frequency of its pulses, the eel can cause the muscles of nearby animals to contract, effectively making them reveal their location. This technique, known as remote control, is another unique adaptation that gives the eel a predatory advantage. In addition to hunting and defense, the electric eel uses its electric fields for communication. Lower voltage discharges serve as a kind of electric speech, allowing the eels to signal their intentions to other eels. Such communication is essential during mating and territorial disputes, enabling the eels to coordinate their actions without physical interaction. The electric eel's electricity-generating abilities are a potent example of how evolutionary processes can mold an organism's physiology and behavior to adapt to its environment. Over millions of years, the electric eel has turned a simple sense organ into a multifaceted tool for hunting, defense, and communication. Its ability to generate and manipulate electrical discharges is a testament to nature's innovation, demonstrating the remarkable adaptability of life in response to the challenges of survival. The Amazonian alligator, a powerhouse predator. Ruling the waterways of the Amazon is a creature of raw strength and tenacity, the Amazonian alligator, also known as the black caiman. This apex predator plays a vital role in maintaining the ecological balance of the Amazon's complex ecosystem, being both a hunter and a guardian of its water territories. The black caiman, Melanosuchus niger, is the largest member of the alligator family and one of the biggest reptiles in the Amazon rainforest, growing up to 6 meters long. Its body is armored with thick, hardened skin that provides effective defense against most threats. Its eyes, set high on its head, are adapted to see in low light conditions, an adaptation beneficial for nocturnal hunting. A large, powerful jaw lined with sharp teeth dominates its broad snout, capable of delivering a deadly bite. These alligators are opportunistic predators, their diet varying with age and size. Juveniles feed on a variety of prey, including invertebrates, fish, and amphibians. As they grow, their diet shifts to larger prey, such as larger fish, turtles, and mammals. They are patient hunters, often waiting motionless in the water for unsuspecting prey to come within reach before striking with terrifying speed and precision. The black caiman plays an important role in its ecosystem. As apex predators, they help control the population of other animals, preventing overpopulation and maintaining a balanced food web. Their presence influences the behavior of other animals, causing changes in the feeding and movement patterns of their potential prey, indirectly shaping the environment. Despite their formidable nature, black caimans are not invincible. They face threats from human activities such as hunting for their valuable skin and meat, and habitat destruction due to deforestation and pollution. Although they are now protected under international law, their population recovery has been slow. When it comes to their interactions with electric eels, their predatory instincts can lead them into dangerous situations. Their thick skin offers some protection against the electric eel's shocks, but it is not entirely insulating. Should they attempt to prey on an electric eel, they risk receiving a powerful electric shock. While not typically fatal in and of itself, the shock can stun the alligator, making it vulnerable to other threats. An incapacitated alligator might be unable to swim, potentially leading to drowning, or it could become prey for other predators. Despite this risk, alligators may still attack electric eels due to their opportunistic nature. The eel's size and sluggish movement might make it seem an easy meal, but the alligator's instinctive bite could trigger the eel's electric defense. The ensuing encounter is a clash of titans, with the eel's shocking defense meeting the alligator's biting offense. In the struggle for survival, both creatures bring their unique adaptations to bear, making every encounter an unpredictable confrontation. The electrifying encounter. Nature's theater is fraught with spectacles of survival, and one of the most electrifying confrontations occurs when the Amazonian alligator crosses paths with the electric eel. This unexpected encounter is an extreme test of survival instincts, a brutal reminder of the harsh realities of the animal kingdom. The electric eel, despite its unassuming appearance, possesses an exceptional defense mechanism, an ability to generate and control powerful electric shocks. Conversely, the Amazonian alligator is a dominant predator, its size, strength, and opportunistic feeding habits often placing it at the top of the food chain. When the paths of these two creatures cross, the resulting clash is an epic display of nature's raw, untempered power. Usually, an alligator encounters an electric eel when it perceives the eel as potential prey. The alligator's opportunistic nature, combined with the eel's slow movement, makes it a seemingly easy target. However, once the alligator attacks, it triggers the electric eel's defense mechanism. The eel responds to the threat with a powerful electric discharge, momentarily turning the predator into the prey. The high-voltage shock from an electric eel can be up to 860 volts, significantly higher than the tolerable limit for most living organisms. The sheer intensity of the eel's electric discharge is enough to stun or temporarily paralyze the alligator. This incapacitation can be lethal to the alligator in a number of ways. Firstly, the shock could immobilize the alligator's muscles, including those responsible for swimming and floating. This could lead to the alligator sinking and potentially drowning if it cannot recover in time. The alligator may also suffer from a loss of orientation, increasing the risk of collision with underwater obstacles or getting trapped in vegetation. Secondly, the electric shock could affect the alligator's nervous system, disrupting the coordination of its movements and reducing its overall mobility. This temporary paralysis may leave the alligator vulnerable to other threats in the vicinity, including other predators that may seize the opportunity to attack. The likelihood of an alligator dying from the eel's shock depends on various factors, such as the alligator's size and health, the strength of the eel's discharge, and the duration of the shock. Although not common, fatalities have been documented, serving as stark reminders of the eel's remarkable defensive capabilities. Yet, even in the face of such a potent defense, the Amazonian alligator, driven by its powerful instincts, may still attempt to prey on electric eels. This testifies to the relentless struggle for survival in the wild, where risk and opportunity often come hand in hand. The alligator's formidable predatory instincts meet the eel's electrifying defense in a dance of life and death, each creature wielding its evolutionary adaptations in a battle for survival. Historical observations and research. The mysteries of the animal kingdom have long intrigued the human mind, and one creature that has consistently piqued curiosity is the electric eel. From the indigenous communities of the Amazon to modern scientists, many have attempted to understand this creature's electrifying abilities. One of the most compelling records of its nature and its interactions with other animals comes from the famed naturalist and explorer Alexander von Humboldt. In the early 19th century, Humboldt embarked on an extensive exploration of the South American continent. One of his most remarkable encounters was with a group of electric eels in the Amazon rainforest. His detailed account of this event continues to captivate natural historians, providing a unique insight into the world of these fascinating creatures. According to Humboldt, during one of his expeditions, local indigenous people guided him to a muddy pond swarming with electric eels. They sought to capture the eels for him to study, but found the creatures too elusive and defensive, frequently releasing their high-voltage charges. To coax the eels into using up their electric discharges, the locals strategically drove wild horses and mules into the pond. The resulting scene, as Humboldt described, was both terrifying and mesmerizing. The eels, feeling threatened by the intrusion, attacked by administering powerful shocks, resulting in a chaotic struggle of splashing water and panicked horses. Some horses were stunned by the shocks, others drowned due to prolonged exposure to the electric attacks. This shocking spectacle offered a dramatic demonstration of the electric eel's formidable defensive powers. This historical encounter, as horrifying as it may seem today, provided some of the earliest and most detailed observations of the electric eel's abilities. Humboldt's descriptions prompted further scientific investigations into these unique creatures. His vivid accounts also served to fuel public fascination, solidifying the electric eel's place in popular culture as a creature of awe and fear. Modern science has since made significant advancements in understanding the electric eel. We now know that these creatures are equipped with specialized cells called electrocytes. These function much like batteries, stacked end to end, allowing the eel to produce its infamous electric shock. It's an adaptation that has made the eel one of the most successful predators of the Amazon basin. Research has also shed light on the role of the eel's electric discharge in communication and navigation. Scientists have discovered that electric eels generate two types of electric organ discharges, low voltage and high voltage. Low-voltage discharges, or doublets, are used for electrolocation and communication, while high-voltage discharges, or volleys, are used for hunting and self-defense. Recent research has further uncovered that electric eels can exhibit predatory behavior and are capable of leaping from the water to directly shock potential threats, a behavior Humboldt also recorded in his writings. Humboldt's early observations of the electric eel and its interactions with other creatures have thus played a significant role in guiding modern scientific exploration. His records serve as a reminder of the historical curiosity these creatures have inspired and the lengths to which researchers have gone to uncover the secrets of the natural world. Electric eels and human interactions. Electric eels and humans have interacted for centuries, with encounters ranging from fearful respect to scientific fascination. The indigenous peoples of the Amazon basin have known of these creatures and their remarkable abilities for generations. Their experiences, folklore, and cautionary tales have played a crucial role in shaping our understanding of these incredible fish. However, with the advance of scientific research and exploration, our interaction with and understanding of electric eels have vastly evolved. While electric eels do not seek out human interaction, their defensive electric discharges can pose a risk to unsuspecting or ill-prepared humans who venture into their habitat. An electric eel's shock is not typically deadly to a healthy human, but the experience can be intensely painful. In water, a powerful shock can cause temporary paralysis, leading to potential drowning if the individual is unable to reach safety. On land, the shock may cause a person to fall or react in a way that could lead to injury. Moreover, people with underlying health conditions, particularly heart conditions, are at a greater risk. The electric shock could potentially trigger heart complications or arrhythmias, which could be life-threatening. Therefore, while the eel's shock is not inherently lethal, the secondary effects can pose serious risks. As such, interactions with electric eels in the wild should always be approached with extreme caution. Despite these potential dangers, electric eels have proven invaluable to scientific research. The study of their electric organs has offered remarkable insights into bioelectricity, a field that holds promise for various medical and technological applications. For example, understanding how electric eels generate and control electricity could inspire new designs for batteries and power generators. Similarly, the way eels use electricity for navigation and communication could offer insights into developing new types of sensors and communication devices. Medical research also benefits from studying electric eels. The eel's electricity-generating cells have similarities to the cells in our hearts and nerves that produce electrical signals. Therefore, by studying how these cells work in eels, scientists can gain insights that could be applied to understanding and treating human heart and neurological conditions. Furthermore, the study of electric eels has expanded our knowledge of animal behavior and ecology, particularly predator-prey dynamics. The electric eel's unique adaptation demonstrates the incredible diversity of life in the Amazon rainforest and highlights the complexity of this ecosystem's dynamics. In the realm of conservation, understanding the ecology and behavior of electric eels is vital for their protection and the protection of their habitats. As the Amazon rainforest continues to face threats from deforestation and climate change, the study of its unique inhabitants, like the electric eel, can guide conservation efforts and emphasize the importance of protecting these diverse ecosystems. The significance of electric eels in ecosystem. The electric eel, a unique creature of the Amazon basin, performs a remarkable and significant role in the ecosystem it inhabits. As an apex predator, it contributes significantly to maintaining the biodiversity and balance of the ecosystem. These fascinating creatures, through their survival strategies and fascinating electric abilities, also influence the surrounding habitats and species in more ways than one. Electric eels inhabit a broad range of aquatic habitats in the Amazon and Orinoco basins, including rivers, streams, swamps, and flooded forests. These ecosystems are renowned for their biodiversity, hosting thousands of plant and animal species. As apex predators, electric eels play a key role in controlling the populations of their prey species, which include fish, amphibians, and occasionally small mammals and birds. This predation helps to prevent any single species from becoming overly dominant and disrupting the balance of the ecosystem. Additionally, the electric eel's unique hunting strategy influences the behavior and evolution of other species within their habitat. Their ability to produce electrical discharges may pressure other species to evolve specific adaptations for survival. Some species may develop resistance to the eel's electric shock, while others may learn to avoid eels or alter their behavior to reduce the risk of predation. These pressures can drive the diversification of species and contribute to the biodiversity of the ecosystem. Electric eels also influence their ecosystem through their breeding behavior. Males build nests out of saliva and guard the eggs until they hatch. This behavior can impact the distribution of other species within the habitat. The nests provide a focal point for other organisms, including potential predators, scavengers, and parasites, influencing their spatial distribution and interactions. In the broader ecosystem, electric eels also play an essential role in nutrient cycling. As predators, they help to control the population of their prey, which can influence the availability of nutrients in the water. When they excrete waste, they return nutrients back into the environment, which can be used by plants and other organisms. Additionally, when electric eels die, their bodies provide a source of nutrients for scavengers and decomposers, further contributing to the cycling of nutrients within the ecosystem. However, it's crucial to note that the ecological role of electric eels, like many other species in the Amazon, is threatened by human activities. Deforestation, pollution, and climate change pose significant threats to the Amazon's aquatic ecosystems. Changes in water quality or the loss of habitat could have profound impacts on electric eels and the ecosystems they inhabit. Conservation efforts are crucial to protect these unique creatures and the vital roles they perform within their ecosystems. The ecological significance of electric eels extends beyond their immediate habitats. They have become a symbol of the Amazon's remarkable biodiversity and the intricate web of interactions that sustain life in these rich ecosystems. As scientists continue to study these creatures, each discovery sheds new light on the wonders of the natural world and emphasizes the importance of biodiversity for the health of our planet.